Hi all, this is BRR. Today's topic is garbage collector. It is working is in .NET environment. So nowadays, the garbage collector, holds the primary role in the CLR, where it is allocating memory for the objects when you create an object in .NET. So when you develop any application and running that application under an IAS, so it creates a memory like a stack and heap memories. It stores the the environment variables and data declared variables and like value type and reference type into a stack and heap memory. So this stack memory contains the value type variable addresses and the value storing in the stack memory, and the reference type things are being stored in the heap memory. So compared to stack memory, heap memory is very slow because it has some reference type, and again indirectly it connects to the stack memory. But when it comes to stack memory, it has a direct reference for the value type variables. Like if you declare a variable with integer and float, long kind of thing, these are the value types are going to be directly stored in this stack memory. When it comes to reference type, indirect kind of things like array strings and class objects, these are going to be stored in heap memory, and again the actual values being stored in stack memory. Indirectly it refers to the stack, so it is always slow. Anyway, both are stored on the computer's RAM only, but comparing to heap memory, stack is somewhat faster. That's fine. Like that is what the comparison between stack and heap. But coming to the garbage collector, when you start creating any objects using in a .NET language, either it is C#.NET or VB.NET, the CLR allocates memory for the objects in the heap. This process is repeated for each newly created object, but there is a limitation to everything. Memory is not unlimited for all, and we need to clean some unused space in order to make room for new objects, right? Because if you are going if you're going to creation of objects like without clearing of the memory objects, and it's some later stages, sometimes it is throw you an exception saying that out of memory kind of thing. So further, so CLR comes into the picture, and it will dynamically pick the objects which are not being used, and it will free the memory. Okay. So this GZ garbage collector works on managed heap, which is nothing but a block of memory to store objects. When a garbage collection process is put in motion, it checks for the dead objects and the objects which are no longer used. Then it packs the space of live objects and tries to free memory so that you will create starting objects. Okay. So how it is going to work internally in the memory? So as I said, this is memory management is a major concern for any application, whether the application is Windows based or web based. In .NET, CLR has garbage collector that executes as part of program and responsible for reclaiming the memory of no longer used objects. As I said, it looks for no longer used objects, and it will get free from the heap so that we have space to create objects. So the advantages are like GC allows us to develop an application without having worry of memory occupation, like whether it is free or whether it is full kind of things you don't bother about while you are developing an application. So when something happens like about memory, like not having the memory proper sufficient for creating an object, then GC comes into the picture and will clean up, and it will give you the free space. And second one is it allocates memory for object efficiently on the managed heap. Yeah, that is what the thing we are saying about the cleaning of dead objects. And third one is it reclaims the memory for no longer used objects and keeps the memory free for future allocations. So what are all the dead objects it has been identified, marked as unreferenced? This can be removed and reclaim the memory and keep the free memory for future allocations of the object creation. And last one is it provides memory safety by making sure that an object cannot use the content of another object. Yes, this provides a memory safety, like make sure the object cannot use another content of another object content, because if there are like more than one object is being placed in the memory and one object content is being accessed by another object, this kind of safety we didn't see this characters collector because it is taking care of everything based on the address or based on the reclaiming process. It takes the memory safety, so that definitely making sure that the object cannot use or access the object. So these are the advantages of garbage collector in .NET. Now, how memory is going to be allocated when you start creating an object? So when you start creating an object using a new operator, like if you're doing this process in .NET, so you're using a new operator and it's short for VB.NET, and when you start creating an object with new operator, this operator first makes sure that the bytes required by the new object fit into the reserved region or not. Like, let us say I have 2 MB memory space in the system, but almost 1.5 MB space has been occupied by other objects, and only 0.5 MB have a free space, but my objects are taking more than 0.5 MB space. Then that time what it will do is it will capture to the memory heap, and it will check for no longer live objects and marking as unreferenced, and then clean up and reclaim the process and use the space for new objects. So if space is available in reserved region, if the object fits, then next object pointer, this is the pointer is nothing but an reference of your object address. So points to the object in the heap like this. So an object's constructor is called the new operator returns the address of the object. Yes, this is returning in the address of your object. So where it is being stored, so that it will recognize when you assign or get the value from the object faster. Now this is how the heap memory is allocating this address. This is address. This is address belongs to this object. This object. This object. If you look at these objects like 10 objects from 1 to 10 object, we have been seeing some of the objects have been dead object because not being used longer time. That's why it's marked as dead object. Now, how the memory being created and put or decide like what are the objects are not being used long time, what are objects are not being used shorter time, like how it is being categorized in the CLR is it is going to use the terminology called generations. We have been come up with 3 generations: generations 0, generations 1, and generations 2. If you look at the next screen, the memory allocation generations, like generations. If you look at generation 0, this is the latest generation and contains the newly created objects. So if you look at here, I'm having 10 objects, but these 2 are the latest objects. So these latest objects are being placed in the generation 0, and that is nothing but short-lived objects and collected frequently. These objects that survive the generation 0, later it promoted to generations 1. So nothing but these are the temporary objects. And coming to generations 1, contains longer life objects that are promoted from the generation 0. So from this generation 0, if you are not using it some sort of time, those are being promoted to generation 1 that are named as longer life objects. These longer life objects survive generations 4 are promoted to generations 2. Basically, this generation serves the short-lived objects and long-lived objects differences. Go for okay. And coming to generations 2, this is nothing but longest live objects have taken place and promoted from generations 1 and collected frequently. So these 3 are interrelated basically. Generation 0 means it contains the latest objects, recently created one, and later it promoted to generations 1, and coming to generations 1, it has been promoted from generation 0, it has some longer lived objects. And then generations 2 has been promoted from generations 1, it also has longer lived objects. Okay. If you look at the working process of garbage collector, like how it is marking longer lived and short lived and temporary. So first one is a marking base, like how it is going to mark object is longer lived or short lived or dead object. And second thing is reallocating phase. Once it has been detected that it is a longer lived object and not using it, then it will mark them as a dead object, and it will remove it and it will reallocate the memory so that you will have free space. The third one is compacting phase. It's compressing phase basically. So based on the reclaim process, it will look for the available space and it will place the new objects in the reclaim process. If you look at the diagram before reclaims, now I have these many objects like 1 to 10 objects. So this is points to this latest one, this is this address, and this is this to this address. So like this, all the relevant address has been replaced. If you look at here, this recently created object has been and generation 0 place, and this is 10 to 7, and 6 to 3 are been generations 1, and 3 to 1 has been generations 2. But in this latest generations 0 objects, one of the object has been dead because the GC has been marked as unreferenced. That's why it has been placed in the dead object. So, and coming to generations one also, one of the object this is has been placed as dead object, and here also dead objects. Now, after reclaiming the process, it will remove these dead objects and it will claim the memory and give the latest memory as like this. So it has been removed dead objects and it has been given latest as generation 0 contains only this one, generation 1 contains only this 3, and generations 2 contains only these 3. So like this, it will reclaim the process of memory and it will give you the latest memory. But my question is, everybody thinking that how the object has been marked as dead. That is what the major question everybody has, because nobody knows internally how the memory or the the GC has been marking my object has been dead. So if you look at the next slide, so garbage collector determines whether any object in the heap is dead or not being used by the application. If such object exists, then memory used by these objects can be reclaimed. That is what the process. But how the garbage collector know about these objects? And when you create an object from the application, we have set of roots, and these roots identify the storage locations of the objects on the managed heap. If you look at here, when you create an object, so it has been some root here. If you look at here my root, so my first object has been created under this root, and the third object is this root, and fourth object is under this root, sixth object is under this root, and 10 object under this root, but this is being referenced again this sixth object, and this third object has been again referenced in 8 object. So overall summary, if you can take it, so my objects which are having roots are like 1, this is having a root, and 3, this is having a root, 4, this is having a root, 6, this is having a root, and 10 having a root, but it has dependence with 0, 6, 6 object. That's why the roots are 1, 3, 4, 6, and 8, 10 also, because 8 has been referenced here. Like if you look at here, 8 has been referenced in this particular root, and 10 has been referenced under particular this root. So overall, this live objects has been identified based on roots, and these are the live objects. And rest of the other objects like 9 and 7 and 5 and the 2 objects has been dead. So this has been marked as dead, and they reclaim the process, and it will give you the clear free memory. The latest memory acquired objects has been like this. This is my next point, the latest object 10, 8, and this is the root 1. I mean, this is the root, and this is another root. This is another root. This is how the just here comes to the picture and marking them as dead objects. So whatever the objects are created from the application are not having their proper root, then those objects can be marked as dead objects, and it will reclaim the process, and it will push it into delete stack, where it will delete unreferenced objects and reclaim the process, and memory will get refreshed, and it will list down like this with the latest roots. So this is how it is going to be generate the reclaim the memory process for the newly created objects. So hope this clears like how this is going to be working as part of CLR, like coming to the memory process creating of this object space like the heap memory. So as I told you that the objects are being marked as generation 0, generations 1 and generations 2, and generations 1, 0 and 2. These are the 3 areas where our entire application objects has been stored into these areas. Generation 0 always contains the latest objects. This is temporary purpose. This is nothing but short-lived objects, and generations 1 contains the longer-lived objects which are promoted by generation 0. Generations 2 contains long-lived objects which are promoted from generations 1. So in these 3 areas, whatever the objects are not having proper root, those will get marked as unreferenced, nothing but dead objects, and it will remove it from this heap memory, and it will reclaim the memory, and it will free up the space for coming up objects in the development. Hope this clears like how this is coming out and clearing the memory space. And for more videos, please subscribe, and surely it will help for the developers who are being into the .NET.